Oh, y'all. So, like I said, 9.6, solving exponential and logarithmic equations. All right, so we're going to start out. The first half of this is solving exponential equations. So we're going to put our steps to solving exponential equations. And then later on, we'll come in and we'll put our steps for the logarithmic, okay? So the first thing we want to do, if it's possible, we want to rewrite each side using the same base. So remember, the base is the number that the exponent applies to. Because y'all, if it's possible to rewrite each side using the same base, I can invoke what we call the base exponent property. So we'll use the base exponent property. And the base exponent property tells me if I got a to the x equal to a to the y, if these bases are the same, then by default, the exponents have to be equal. So then I could just set my x equal to my y. And y'all, once I do that, I just solve for the variable. And y'all, then I'd be done once I solve for that variable. So easiest thing is to hope that we can rewrite each side using the same base. If we can't rewrite each side using the same base, so if I cannot rewrite each side using the base, then the first thing I'm going to do, I'm going to take a log of both sides. Now, y'all, once I take a log of both sides, the reason I'm doing that is so that I can bring them exponents down, remember. So what I do is using the power rule, bring the exponents down, and rewrite as a product. So remember, if you have log of some number to an exponent, that was usually the last step we did, was always bringing them exponents down to the front. So that's what I'm talking about here. We're going to bring them exponents down because now that they're not sitting up there as an exponent and we brought it down, at that point, we can solve for the variable. Now, anytime you got to do this step 2 to solve it by using your logs, we got to round off the final answer. So round the final answer four decimal places. Okay, so remember, the first thing we hope we can do is rewrite these. If we cannot rewrite them, then we got to do all this log stuff, okay? So y'all, let's start playing with these. So we're going to start out, and these are just going to say solve for X. So y'all, number one has 2 to the X equals 32. So what I really want to know is, can I rewrite 32 as a 2 to an exponent? So y'all, we can definitely, so what I'm going to do here, I'm going to rewrite 32 as 2. So let's see, we got 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. I did that 5 times. So I'm going to rewrite the 32 as 2 to the 5th power. So I'm going to come down and do my 2 to the X equals 2 to the 5th power. Well, my bases match now. So since my bases match, we had a property up here that said, hey, if your bases match, then your exponents have to be equal. So that means that this exponent of an X has to equal this exponent, which is a 5. Y'all don't have to solve for the variable because it's already solved on this one. So let's check this. If I put a 5 in for that X, 2 to the 5th power will equal 32. Y'all, they're not too bad. You just gotta try and see if you can get the right side from using that left side as your base, okay? So we'll try another one here. So number 2. Number 2 wants me to solve for X. I got 6 to the 4X equals 216. So y'all, let me show you what I would do to check this. See if, because I want to see if I can rewrite that 216 using that 6, okay? So what I would do is I'll just get my calculator, and I'm just going to start multiplying 6 until I see if I can get that 216. So 6 times 6 gave me 36. I multiply that by 6. I get 216. That's the number I did it. So I multiplied 6 3 times to get that 216. So I'm going to go back to our paper. So this one I can actually rewrite 216 as 6 to the 3rd power. So we'll replace that with the 6 to the 3rd. So I got 6 to the 4x equals 6 to the 3rd. So once again, the bases match. Since these bases match, that means that 4x has to equal to 3. And y'all, that's the nice thing about this. Once you can get these bases matched, the exponents have no choice but to be equal. And on this one, I got to go a little bit further. So I'm now going to solve it for that X. So y'all, to solve this one, I'm just going to divide both sides by 4. So the 4's cancel, giving me a 1x on the left side. Ooh, can't do nothing with that 3/4. So that's going to stay a 3/4. All righty, so we pray that we can rewrite them like that, okay? But y'all look at this one. I've got a 2 to the x equals 23. Well, guess what? There's no way I'm rewriting a 23 using a 2 as the base, because that's an odd number. So a 2 can't be multiplied by itself and end up with an odd number. So we cannot rewrite this one. So can't be rewritten. So remember, I said if it cannot be rewritten, we're going to take a log of both sides. Because remember, what you do to one side of that equation, you got to do to the other side. And the only way I can bring this x down so that I can solve it is if I take a log. So we're going to take a log of both sides. All right, y'all. We're going to invoke the power rule. This x exponent, we're going to bring that down to the front and write this as a x log 2 equals a log of 23. Y'all check this out. Our last step to get this x by itself is to divide both sides of this equation by that log 2. So I'm going to bring down my x log 2, divide that by log 2. Those log 2's will cancel out now. But if I divide this side by log 2, I got to go to the right side and divide it by log 2. Now, these logs cancel, giving me my x. Now, we have no choice but to use a calculator on this. But y'all, here's the thing. When you punch log, it'll give us a parentheses. We got to close each parenthesis before we go to the divide. And then down here, I need to put my 2 in parentheses. So let me share that calculator and show you what I'm talking about. So notice if I hit log, it gives me the first parentheses. I'm going to put in my 23. And then I'm going to close those parentheses. And then I'm going to hit my divide. And then I'm going to hit log. And I'm going to put in the 2. And close parentheses. So now remember, we got around this 4 decimal places. So we're going to get a 4 point. Let's see, we got 5, 2, 3, 5. But behind the last 5 is a 6. So we're going to round that 5 up to a 6. So we're going to get 4.5236. So remember, when you're rounding 4 decimal places, you look at the 5th decimal place to determine what you're doing to that 4th decimal place, okay? Alrighty, y'all, so notice, if you can rewrite the sides, you get nice numbers. But if you got to do the logs, logs are going to give you never-ending decimals, so we got to round them off 4 places. And so, y'all, that's the 2 things I'm going to be doing. I'm either going to be rewriting them with the same base, or we're going to do the logs like that one. All right, y'all, 2 to the 7x minus 1 is going to equal 16. Well, we already know that we can rewrite 16 using 2's. So I'm going to rewrite 16 as 2. So let's think. 2 times 2 is 4. Times 2 is 8. times 2 is 16. We did that 4 times, so that exponent will be a 4. So we're going to replace 16 with 2 to the 4th. So we get 2 to the 7x minus 1 equals 2 to the 4th. So guess what? We did good. Our bases match. So since the bases match, we know the exponents have to be equal. 7x minus 1 has to equal that 4. And y'all, just like up here, at this point, I'm going to solve it for that x. All right, so to solve that, we're going to add 1 to both sides. That's going to give us our 7x. That cancels. 4 plus 1 is 5. And y'all, let's divide both sides by 7. So the 7's cancel, giving me a 1x. Y'all, nothing we can do to that. So that's going to stay a 5 over 7. All right, so any questions on these yet? All righty, y'all, number 5. 3 to the x equals 8. So let's see, the base is a 3. So can I rewrite 8 using the base of 3? Well, y'all, let's see. 3 times...
No.
No, because that's what? 3 times 3 is 9. So there's no way I can rewrite. So we can't rewrite. So y'all, we can't rewrite. We're going to take a log of both sides like we did up here. And y'all, let me tell you a little trick on this. If you look at the answer blanks on this, the ones that can't be rewritten in their answer blanks, they're telling you to round it 4 decimal places. The ones that can be rewritten, all they say is type an integer or fraction. So by looking at the answers, you can tell, hey, if they want an integer or fraction, that means I could rewrite it. But if their answer blank is saying, hey, type an integer or decimal and round the decimal 4 decimal places, that's telling me that I have to use the log stuff, okay? All right, so we can't rewrite, so we're going to take our log of both sides. So a log of 3 to the x equals a log of the 8. And y'all remember, the only reason we took logs of both sides was so we can bring that x down to the front. So we're going to get a x log 3 equals a log 8. Which these ones ain't that bad if you realize all I'm doing in the long run is I'm taking the log of the right side and eventually just dividing by that log of that left side. So divide both sides by log 3. So y'all, the log 3's cancel on the left side, giving me my x. Remember, doing this on the calculator, close those parentheses. All right, so let's see what that's going to give us. That is a log 8 divided by a log 3. So I'm going to hit my log 8, close parentheses, divided by log 3, close parentheses. We're going 4 decimal places, so that's what, a 1.892. The 7 has an 8 after it, so I will round that 7 up to a 8. So I'm going to get a 1.8928. Now, y'all remember, I showed you could set that mode to 4 on your calculator from float, put it on 4. But remember, after you do these problems, switch it back so it don't affect you on other problems, okay? All right, number 6. 10 to the negative x equals 4 to the 5x. So no way I can rewrite a 10 and a 4 using the same base, because 10 squared is 100 already. So no way I'm going to get that out of these two. So I can't rewrite this one. So I'm going to take a log of both sides. Log of 10 to the negative x will equal log of 4 to the 5x. Now I got a variable on both sides, so I got to bring down both the exponents on both sides. So over here we'll get a negative x log 10. On the right side, I'm going to get a 5x log 4. Y'all, what's sad? Every single one of us on this problem, whenever I get for the x on mine, y'all are going to get the same answer on y'all's when y'all do this one. So let me tell you the first thing I want. I want all the x's on one side together. But since all this stuff is being multiplied, I'm going to have to subtract this whole thing from both sides to move it over. So we're going to subtract 5x log 4 from both sides. So these are not like terms, so I'm just going to put them in order. Negative x log 10 minus the 5x log 4 is going to equal 0. Because once I move this from the right side over, that side is now a 0. So let's see what we can do next. I need these x's brought out. So what you're going to do at this point, we're going to factor out the x like a greatest common factor. And that's the only thing these two terms have in common is these x's. So we're going to factor out an x. In parentheses, we now have a log 10. Well, that's a negative log 10 minus 5 log 4, all equal to 0. So I factored out that x as a GCF because that's the only way that I can pull it out of these two terms. So if we want this x by itself, since that x is being multiplied by everything in parentheses, we're going to divide both sides by these parentheses. And that's going to give me 0 divided by my negative log 10 minus 5 log 4. Well, y'all, that cancels on this side, leaving that x. And y'all, guess what? 0 divided by anything is going to be 0. So we don't even have to punch that on the calculator because we got a 0 on top. Once we divide that, we're still going to get that 0. So if you got that variable on both sides in this number 6, like I do, the only answer you're going to get out of that is a 0, okay? So that's sort of tricky. A lot of work just to get a 0. All right, now number 7, I didn't mind it too bad. We're going to solve for t. I got an e to the t equals 525. Hey, y'all, from the past, when y'all see this ET, what's it make you want to say?
Phone home.
Phone home, there you go. All righty, so I'm not going to try to rewrite that 525 using that E for sure. So I can't rewrite this one. But instead of taking a log, I'm going to take a ln of both sides. Anytime you got the E, we want to take a ln of both sides. So we're going to come in and do ln of E to the T is going to equal ln of 525. And in a second, you'll see what I'm using the ln for. Because now I can bring my T down to the front. And I got a T times ln of E equals the ln of 525. But y'all, let me show you. This ln of E, let me show you on the calculator what it's going to equal. So if I come in here and punch my ln button, and then I do second divide to get that E. Y'all watch this. ln of E equals 1. So if ln of E equals 1, this left side now is T times 1. So I got T equals the ln of 525. Okay, so remember, ln of E will always equal 1. So if you got a variable times the ln of E, all it's going to equal is that variable, okay? All right, y'all. So to get our final answer, it says round it 4 decimal places. We're going to go figure out what the ln of 525 is. So let's hit that calculator. So hit our ln, and let me see, I said 525. Hit enter. All right, so we're going 4 decimal places. So I got 6.263. I'm looking at the next 3. It has a 9 after it. So I'm going to make that a 0.2634. So 6.2634. Alrighty, y'all. So just remember, if I got an E in it, I'm definitely using LNs. For anything else, I'll do the logs, okay? And y'all, tell you, once you play with these a little bit, they're not that bad. All right, what's this give us? 8. So let's see. 8, I have E to the negative 0.50 T. That's going to equal 0.30. Y'all, once again, I don't think I'm going to try to rewrite this 0.3 as an E. So I cannot rewrite again. So we're going to take an ln of both sides because we got our E here, okay? So we're going to do ln E to the negative 0.50 T will equal to ln of a 0.30. Now, you know, once they start breaking out the decimals on you like this, they're really starting to try to challenge you because they know y'all got them regular numbers and all that down. So they're just trying to make these look different to challenge you. Well, y'all, guess what? All I got to do, I'm going to bring down that negative 0.50t, put it in front. Now, do we even need to rewrite that ln of e here? Because y'all know what the ln of e equals. But let's bring it down just for a second. And then on the right side, we got our ln 0.30. So remember, ln of e equals 1, so I can move it out. That's going to give me negative 0.50t equals the ln of my 0.30. Yeah, so that's a big move in calculus. They do the LNs when they got the E, so they can basically just bring them exponents down. So now look at this. Negative 0.50t. If I want to make that a 1t, I'm going to divide both sides by that negative 0.50. And that'll equal the ln of our 0.30 divided by negative 0.50. So notice this cancels, giving us our t. So now on this one, I'm going to punch that in. Remember, I'm going to put my parentheses around that 0.30, okay? So let's go punch that one in. So we got our ln, and that was 0.30. Close our parentheses, divided by a negative 0.50. And y'all, guess what? That one said, hey, round it on the final answer. So hit enter. All right, so we get a 2.4079. Oh, but the 9 has a 4 after it, so the 9 does not change. So that'll be 4079. All right, y'all. So guess what? One more exponential, and then we're going to do the logarithmic, okay? Ooh, but let me see what they gave us. They gave us 12 to the x equals 4 to the x plus 2. So y'all, this is going to be the one where you get the headache. To me, this is probably one of the trickiest ones in all this homework. I can't rewrite 12 using a 4 as a base because 4 squared is 16. So no way I'm rewriting it. So I can't rewrite. So I'm going to take logs on this one because I don't have the E. So a log of 12 to the x equals log of 4 to the x plus 2. We did that so that we can bring all these exponents down to the front. So the left side, I'll get an x times log 12. Now, y'all, the trick on the right side, you got 2 parts to that exponent. So when we bring that one down, we need it in parentheses at first. So put the x plus 2 in parentheses times the log 4. Now, I'm going to now get rid of these parentheses. So bring down your x log 12 Both of these inside the parentheses have to multiply by the log 4. So you would do x times log 4 would give you a x log 4, plus you would do the 2 times the log 4 and get a 2 log 4. So that's the main thing you got to realize on the right side. Since you had 2 parts to that exponent, when you bring it down, both parts got to multiply by the log 4. Y'all, you know what I want to do next? I need all these x's over here. So I need to move this x log 4 to the other side. So we're going to subtract x log 4 from both sides. Now, I really can't subtract them at the moment because they're not like terms. So that's going to give me an x log 12 minus x log 4 equal to, well, if the x log 4 is canceled on the right side, on its left is the 2 log 4. So let me see if y'all remember this step. What can I do? Because I got x's in both of these terms. What can we do to make that maybe a single x?
Factor.
Factor, that's it, perfect. Because they both got an x. So we're going to factor out our x. And we'll get a log 12 minus log 4. That's going to equal your 2 log 4 on the right side. So y'all, how about my last step on this? Make that x a 1x over here.
Minus in the logs.
Well, they're being multiplied, so you don't want to minus them, but you want to come in and divide them both. So divide both sides by log 12 minus log 4. So this side will be a 2 log 4 divided by a log 12 minus a log 4. So these do cancel, so that's bringing our x down. Now, y'all, I ain't going to lie. On this one, let me show you what I would do on the calculator so that you can make sure that you get this right. I'm going to make it look like a fraction because we all have the power to hit alpha y equals and then enter for the ND. On top, we had a 2 and then a log 4, close parentheses. On the bottom, we had a log 12. So you want to hit log 12, close those parentheses, and then minus the log 4, and then close those parentheses. You know, that's the easiest way to do this one. Because if you punch in 2 log 4 divided by log 12 minus log 4, if you do it the way I was doing them earlier, you got to put the entire bottom in its own set of parentheses, or the calculator won't know what the top and bottom are. So if you hit alpha y equals, you can make this thing look exactly like what we had on that paper. So hit enter, round me 4 decimal places. So we get what, a 2 point, what's that, 5237, a 1 after the 7, so it will stay a 7. So we get 2.5237. Now, I won't put none quite so challenging as this one on your test, okay? You just got to know it long enough to knock it out on your homework. So that was solving exponential. Now we need to figure out the steps to solving logarithmic. So the first thing you have to do on one side or the other of your equation, if you got more than one log, you got to combine those logs. And I was doing that stuff we did yesterday. So if needed, combine logs on either side of the equation. So remember, if they're being added, I'm going to write them as a product. If they're being subtracted, I'm going to write them as a quotient. So it's going back to that product rule and quotient rule for logarithms, okay? And then at this point, do we have a log base equal to a log base? So if yes, then we're going to invoke what we call the log base property. So if yes, use the log base property. So y'all, the log base property tells me this. If I got a log base A of X on one side equal to a log base A of Y on the other side, and this is really similar to that exponent base rule, but if the logs match the bases on each side, then that means that this result has to equal that result. So that means then X equals Y. Okay. Now, at that point, I would solve for that variable. But guess what? You might not even have a log base on each side. So we won't have this happening. So if not a log base equal to a log base, then what we're going to do, we're going to rewrite them as exponential. So that's why in 9-4 we had you learning how to rewrite stuff as exponential from log and then from log to exponential. Well, so you can do this stuff right here. You're going to rewrite it as exponential. You're then going to solve for the variable. Now, here's the big thing on the log equations. You might want to check your answers on these. Because remember, we cannot accept negative answers for our log equations. Because y'all remember what happened when you tried to take a log of something like a -5?
It was given an error, wasn't it?
It was giving you an error. And remember, that meant it did not exist. Okay. So on these kind of problems, some of them we will get two answers. One will be positive, one will be negative. Well, y'all, we got to throw out that negative answer because we cannot have a negative log. Okay. All right, so let's play with some of these. Well, we'll do one and we'll probably have time for one and then we're doing our break, okay? So let me see. These start at number 10, and guess what? They say solve for x. So number 10, I got a log base 2 of x equals 4. So if you notice a while ago, when I had the exponential, if I could rewrite them with the same base, that was fine. But to solve the exponentials, I had to take logs. Well, here, if I don't have a log on both sides, I got to solve the logs by doing the exponential stuff. So guess what? We do not have a base on a log on both sides. So the only thing we can do, we're going to rewrite this as exponential. So let me see if y'all remember. The base is going to equal the base of the logarithm. So bring down your 2 as your base. The exponent for the 2 will be the exponent of the log, which is the 4. So we now have 2 to the 4th is going to equal that result of x. So y'all remember, base, exponent, result. Okay? Base, exponent, result. Well, y'all, you got one step to solve that. You got to figure out what is 2 to the 4th power going to equal. So you got what? A 2 times a 2 times a 2 times a 2. So that gives us what? 16 equal to our x. So to check this, log base 2 of 16, if you want to check your answer, you got a calculator, right? So let's go to our log base that's in the math button. Hit enter. So we're saying that a log base 2, we got 16 for the x. When I hit enter, that's got to equal that 4. And then there we go. All right, y'all. So we're right at, so let me stop my share for a second. I'm going to pause this. All right, y'all. So number 11 has a log x equals -4. So don't have a log on each side, so we can't do the log base. So we're going to rewrite it as exponential. So y'all, here's the question. What's my base? Because I don't see a base.
1. No, 2.
10.
10. I like that. And remember, if there's no number here, y'all got to treat it like a 10. Okay. Y'all, math hides a lot of numbers from you. So we're going to rewrite this as exponential. So we got our 10. Exponent is a -4, and that's going to equal that x. So on this one, the trick is figuring out what that 10 to the -4 equals. So y'all, I'll tell you what, when you got a -4, that means you're going to have your point, and then 1, 2, 3, 4, and then our 1, and that's going to equal x. So if you got a well, let me show you. Let's see if our calculators will do that.
Mine gave me an error.
What did it give you? E?
It just says non-real numbers.
Oh, when y'all did 10 exponent -4 enter. So I'm getting 1e -4, which is basically you take the 1 and move that exponent left 4 times.
I suppose I could have done that wrong.
Worked, but I don't know.
That's what I got.
What'd y'all get?
I got the 1e -4.
Yeah, and that's doing scientific notation talk with us. So watch this. If I do 0.0001 and put enter, see how it's giving me the same thing? So you need a 0.0001 equals the x. If you had a 5, that'd be 0.00001. But you got 4 decimal places and then the ones at the end. So yeah, I don't like this problem a lot because it only lets you write it in that one way. So yeah. Yeah, some of these questions, MathLab only lets you write it one way, so I ain't too big on those ones. But y'all, that's the only one that's sort of jacked up like that. Watch this, number 12. Log base 4 of 5x minus 4 is going to equal 1. All right, guess what? I don't have a log over here, so I'm going to rewrite this one again. So we're going to rewrite it as exponential. My base is the 4. My exponent is the 1. And that's going to equal 5x minus 4. So this one's not bad. 4 to the first is just a 4. And y'all, now to solve this for the x, we're going to add 4 to both sides. And then we'll come in and divide. So notice we get 8 equal to our 5x. I'm going to divide both sides by 5. So those 5 cancel, giving me my 1x over here. Well, we can't do nothing with that, so that's going to stay at 8 over 5. All right, y'all, let's see. What's this, 13? Watch this. Log x plus log of x minus 3 equals 1. So remember the very first thing I said, if you got more than one log on either side of those equals, we got to combine the logs. So we're going to combine the logs on the left side. Since they're being added, we rewrite this as a product. So bring down your log. The product will be the x times the x minus 3. All that's going to equal 1. All right, watch this. I'm now going to rewrite this as exponential. So what is my base? Remember, there's no base shown by that log, so what is it?
10.
10.
So I got 10. Exponent is 1. And that's going to equal to x times the x minus 3. All right, also the right side, we got to get rid of parentheses. Left side, 10 to the first is just a 10. So x times x is an x squared. X times negative 3 is a negative 3x. So y'all on this one, it's got an x squared term. So we need everything on one side equal to 0. So for this one, the easiest thing would be to subtract 10 from both sides. I get 0 equals x squared minus 3x minus 10. So now I got to factor this side to solve it. So we're going to write our parentheses. X squared is an x and an x. The last number is negative. Since that number is negative, one of these is positive, one's negative. All right, another thing, that negative tells me to find factors of 10 that'll subtract, give me 3. So y'all give me factors of 10. So we got 1 and 10.
5 and 2.
2 and 5. So there you go, 5 and 2. Remember, the larger factor has the same sign as the middle. So the 5 will be negative and the 2 will be positive. All right, y'all. Take both of them, set them equal to 0 to get our two solutions. So I'm going to subtract 2 from the first one. I get x equals negative 2. We're going to add 5 to the second one. And we get x is a positive 5. So y'all, here's my question. What would my final answer be? Well, let me ask y'all this. Can negative 2 be an answer? If I put that negative 2 in for that x, can I take a log?
No.
No, we can't take a log of a negative answer. So if you get a negative answer down here, you might as well cross that thing out. The only answer for this one will be a positive 5. So on all these ones where you're going to have to do some factoring, you're going to get a negative answer and a positive. Throw those negative answers away, because if you check them on the calculator, you're going to get that error message, okay?
Could you go over 12 again, like just the steps that you did?
Okay, so the first thing, I didn't have logs on both sides, so I can't use my log base property, so I have to rewrite this. So I came down, my base was the 4, the exponent was the 1, and that equals the result, which is at 5x minus 4. So then at that point, I had basically 4 to the first was 4, equal to my 5x minus 4. So I wanted to solve for the x, so I added 4 to both sides. So that gave me 8 over here equals my 5x. These 4 sort of canceled on that side. And then remember, I want 5x to be 1x, so I divided both sides by that 5, and I ended up with my 8/5 equal to my 1x. And I'll have another one similar to that, I think, coming up.
How many are on this homework lesson?
Do it now.
I said, how many questions are there on this homework?
Oh, I think I got like 4 more.
There's 17.
17 altogether, yeah. The first 9 we're doing the exponential equations, and then the last 8 we're doing the logarithmics. So this is number 14, right? 14, yeah. All right, y'all, watch this one. It's a big one. Log base 4 of r plus 21 minus log base 4 of r plus 5 equals a log base 4 of r. So you know the first thing we got to do, we got 2 logs on the left side. We got to combine these logs. Now, if you remember yesterday, when they're being subtracted, we got to rewrite them as a quotient. The positive stuff will be on top. The stuff being subtracted will be to the bottom. So bring out your log 4. The top is r plus 21. The bottom will be the r plus 5. That's going to equal the log base 4 of r. What do y'all notice something over here? I got a log 4 on the left side. I got a log 4 on the right side. So the log bases match on this. So remember, we said if the log bases match, then that means this result equals this result. So the r plus 21 over r plus 5 equals r. So y'all, let me show you how I would solve this one. And we'll do some of these in support. But I would treat the right side like a fraction by putting a 1 under it. And to solve this, I'm going to do what we call cross multiply. When you cross multiply, you take this top times that bottom. So you're going to have basically a 1 times the r plus 21. That's going to equal the other side where you take this bottom times that top. So the top of one fraction times the bottom goes on one side. The bottom of that one times the other one's top goes to the right side. So my right side will be an r times the r plus 5. Okay. So when you learned about cross multiplying in the past, this was when y'all was doing it. So now distribute, get rid of our parentheses. 1 times r is r plus 1 times 21 is 21. Over here, r times r is r squared. R times 5 is 5r. So y'all notice, once again, I got an r squared term here. So to keep it positive, I'm going to move both of these to this side. We're going to subtract r from both sides. We're going to subtract 21 from both sides. So the r's cancel, the 21's cancel. So all we got on the left side is a big 0. We got an r squared. Now, like terms will be the r's. 5r minus 1r is going to give us a positive 4r. And then y'all bring down your negative 21. So guess what? We get to factor again. We got an r squared. That's going to be an r in an r. Once again, we got a negative at the end. So one's positive, one's negative. This time I know the larger factor will be positive like the middle number on this one, okay? So y'all, we need factors of 21, 1 and 21, 3 and 7. If I need factors of 21, that'll subtract and get me a 4. That's going to be 3 and 7. Remember, the larger factor 7 is going to be positive like the middle number. So the 7 is positive, 3 is negative. So now we're factored, set each factor equal to 0. So y'all, I'm going to subtract 7 on the first one. I get R is a negative 7. I'm going to add 3 to the second equation and get R is a positive 3. So the question of the day, what is your final answer?
3.
3, because we got to cancel out that negative answer, okay? So I'm not going to lie, that log one's not too bad, but when you get to the solving part, most of them are going to have to be factored, okay? Ooh, let's see what we got here. Log base 4 of x plus 1 minus log 4 of x is going to equal 4. So let's see, we got 2 logs on the left side, so we got to combine logs. So y'all remember, these are being subtracted, so it's going to look like a quotient. So bring out that log 4. The positive factor goes to top, that's the x plus 1. The factor being subtracted, that x goes to the bottom. And all that's going to equal that 4. Now, notice on this one, I don't have a log on both sides, so I can't do my log-based property like up here. So, what we got to do, rewrite this one as exponential. So the base is a 4. The exponent of that base is a 4. So remember, base, exponent, result. So that 4 to the 4th power is going to equal a x plus 1 over x. All right, y'all. So what we got to figure out is what is 4 to the 4th power? So that's going to be like 4 times 4 times 4 times 4. So let's see, we got what? 4 times 4 is 16. Times 4 is 64. So y'all, what is 64 times 4 giving us? I think we get 256 equal to the x plus 1 over x. So notice, since I got this fraction over here, I'm going to make the left side look like a fraction by putting a 1 under it. So guess what? We're going to cross multiply again. So this top multiplies by that bottom. So I got 256 times x. Then you take the bottom and multiply by that top. Well, 1 times x plus 1 is just going to be x plus 1. So y'all, I'm going to bring this up here now. So y'all, what would we do? We need the x's on one side. So what's our step here?
Divide, or you could subtract that x or divide.
No, I'm going to do what you just said. I'm going to subtract an x from both sides. So remember, when you're moving stuff, you're just going to really be subtracting and adding. But notice what this gives me. 256 minus 1 x leaves me 255 x's. Those x's canceled. All that's left is 1. So let me write that up here. So if you want to turn this 255 x's into 1x, what are you doing?
Dividing.
Subtract 255.
Oh no, you want to divide, remember, because 255 divided by 5 will give me my 1x over here. And then you divide this side 1 by 255. So notice that cancels, giving you 1x. And then that's going to equal 1 over 255.
Do we keep it as a fraction?
Oh, definitely. Now, if it was like this, 255 over 1, then you could write it as 255. But remember, if that 1's on top, you got to keep that 1, okay? So you notice these log ones are a little bit long, ain't they? By the time you go through them, where those the exponentials we did earlier, they went through pretty quick for the most part. All right, 16. Oh my God, look at all the logs on this one. Log base 2 of an x plus log base 2 of x minus 1 is going to equal a log base 2 of a 6. So what's our first move?
To combine.
Oh, I'm going to combine logs. Good job.
If we have the LNs, do we still combine?
Yeah, but none of these have an LN on them. They shouldn't.
Mine question gave them to me.
So if you get a LN on those, let me know and I'll sort of solve that real quick.
Yeah, on 16 I got one.
A LN.
Yes.
Alrighty, so give me your LN and then I'll solve this and then I'll solve that. So you got a LN.
X in parentheses.
Uh-huh.
Plus ln x plus 1 equals ln 2.
Okay.
And then that first x is in parentheses too.
Yeah, it don't matter. They're just letting me know that that's my LN. Alrighty. So let's work this one and then we'll knock that one out. So over here, we're going to combine logs. They're being added. So it's going to be a product. So come down with log base 2 x times x minus 1. And y'all, on this one, they probably put that x in parentheses too. Now that's going to equal the right side, which is a log base 2 of a 6. But y'all look at this. My bases match. Well, how about my log bases match? I got a log base 2 here, log base 2 here. If the log bases match, that means this result, x times x minus 1, is going to equal this result of a 6. So guess what? To solve this, we're going to distribute our x first. So we get an x times x is an x squared minus x times 1 is x. All that's going to equal 6. All right, so at this point, we want a 0 over here. So subtract 6 from both sides. So y'all notice I get an x squared minus an x minus 6 equals 0. Oh, yay, we get to now factor. X squared is an x and an x. Once again, the last one's negative, so I got a positive and a negative. So y'all give me factors of 6 that subtract to get me that 1 in the middle. So let's see, we got 2 ways, right? 1 and 6 and
3 and 2.
3 and 2, there you go. So 3 is larger, it's going to be negative like the middle. And a 2 is positive. So now really on the rest of this, all we're doing is changing the signs to get these final answers. Remember, the factors always had opposite signs in your solutions. So it looks like I'm getting a negative 2. Then here we're going to add 3. And we're going to get a positive 3. So y'all, final answer.
3.
3.
There you go. So y'all, let's see what we're going to do with this LN. Well, the first thing we're going to do, we got 2 LNs over here. So we're going to combine LNs. They're being added, so they're going to look like a product. You're going to have an LN of your x times x plus 1 will equal your LN of 2. Well, remember, LN is the log base E, log base E. So my log bases match. So my log bases match. So since the log bases match, that means this result equals that result. So the x times x plus 1 will equal 2. All right, so we're going to distribute again. I get an x squared plus an x equals 2. So if you notice, we're working it basically the same exact way, other than they got LNs and we had logs. So remember, right here, I ended up with the same thing. So I had to move the 2 over by subtracting. So I get an x squared plus that x minus 2 equals 0. So now we get to factor that. X squared is an x and an x. That's negative, so I got unlike signs. We only got one guess on these factors, right? The only factors of 2 are 2 and 1. But remember, the 2 is larger, so it's got to be positive and the 1 negative. All right, so then you're going to solve both of these. So if you notice, I'm going to get what, a negative 2 and a positive 1. So you will always get opposite signs on these equations when you're dealing with the logs, okay? But y'all, guess what? Can't take that negative 2, so our only answer is the x equals 1. So see, y'all, don't let them intimidate y'all with them LNs. They're basically the same thing, except instead of a number by those, remember LN is just a log base E, okay? All right, y'all, so I got another one to go. All righty, so I got a log base 2 of x plus 2 plus a log base 2 of x minus 2, that's going to equal a 5. So y'all see it again, right? We got 2 logs over here. So we're going to combine logs. So they're being added. We're going to rewrite this as a product. So bring out the log 2. You'll have an x plus 2 times an x minus 2, all equal to 5. All right, so I don't have a log on both sides. So the only other choice, rewrite this as exponential. So you would bring down the base, which is a 2. The exponent is the 5. Now, the result is the x plus 2 times x minus 2. Now, do y'all realize that these are conjugate pairs here? Remember, if one's positive, one's negative, but everything else is the same. So these are conjugate pairs. So since these are conjugate pairs, instead of doing the big FOIL, I'm going to shortcut FOIL. So I'm going to shortcut FOIL since these are conjugate pairs. So first of all, what is 2 to the 5th power? 2 times 2 times 2 times 2 times 2. If you multiply 2 5 times, you're going to get a 32. Now remember, the shortcut FOIL, you're going to go x times x, which is x squared. And then you're going to do the 2 times negative 2 and get a negative 4. Because what happens, the 2x and the negative 2x, they're going to cancel every time, okay? So y'all going to have something close, x plus 5, x minus 5, x plus 7, x minus 7. They're going to be really close to mine, okay? Now, check this out. I've got an x squared term and numbers, but I don't have the x term on this. So the easiest way to solve this would be to add 4 and do your square root stuff. So let's add 4 to both sides. 32 plus 4 is 36, equal to my x squared. We're going to do square roots. And y'all, what's nice? What's square root of 36?
X.
And that's going to equal the square root of x squared, which is x. I don't have to worry about the negative answer on this one, do I?
No.
Because remember,
No.
I would get a plus or minus 6, but hey, we can't keep the negative answers anyway. So only keep that positive 6 value that you're going to get out of that and be done, okay? So y'all, that is the last thing y'all are learning from me as far as college algebra goes. So what I'm going to do now, I'm going to show you, support had 5 questions. So I just want to play with them real quick. So this is 9.6 support. But y'all, you're going to know how to do some of these. Watch this. X minus 8 over x plus 3 equals 1/2. So what am I going to do to solve that? Y'all remember my first step?
Didn't you multiply when we did that?
Yep, I'm going to cross multiply.
Multiply.
There you go. So remember, this x minus 8 is going to multiply times the 2. So that's going to be 2 times x minus 8. That's going to equal this bottom times that top. So that's basically 1 times x plus 3. So see how it makes a x or a cross in the middle? That's why they call it that. Now get rid of parentheses, distribute your 2. You get a 2x minus 16. Over here, distributing the 1, you're going to get an x plus 3. All right, so I'm going to get the x's on this side, the numbers on that side. So first, I'm going to subtract the x. So 2 minus 1 leaves me 1x minus 16. Those x's cancel, and I got my 3. And y'all, last step, add 16 to both sides. You're going to get x equals, let's see, 16 and 3 give us 19. So these ain't going to be really bad. They just want you to learn how to do this cross multiplying. So watch this. Z plus 4 over Z equals 3 over 2. So guess what? You're going to cross multiply this. So the Z plus 4 times the 2. That's going to give me 2 times Z plus 4. That's going to equal this Z times the 3. So distribute, get rid of your parentheses. 2Z plus 8 equals a 3Z. Now, anytime I got the variable on one side and a variable and a number on the other side, I'm going to move this variable to the side of that one. So I'm going to subtract 2Z from both sides. Now, you can solve these different ways. I try to do them in the quickest way. Because look, these Z's cancel, leaving the 8. And y'all look at that. 3 minus 2 leaves me 1Z. And we're done. So just get used to, it don't matter what side you leave that variable on. Because right here, I could have subtracted 3Z and I would have had a 0 here, but then I'd have started having to do a lot of crazy stuff to it, okay? So I always try to do these in the fewest amount of steps that I can. Oh, y'all look at 3. 8 over 3x minus 2 is going to equal a 4 over 9x. So the 8 will multiply by the 9x because I'm still cross multiplying. And y'all, the moral of the story is if you got a fraction equal to a fraction, that's the easiest thing, cross multiply. So let's see, 8 times 9x will equal the 3x minus 2 times 4. All right, so let's see, 8 times 9, that's what, 72x. Over here, 4 times 3 is 12x minus 4 times 2, which is 8. All right, so I got the variable over here, variable and a number. I'm going to move this to this side by subtracting 12x. So y'all, that's going to give me, what's that, 60x. Those cancel, and I'm left with my negative 8. Then I'm going to divide both sides by the 60. So if you got a number in front of the X, that's what you're going to divide every time. So those cancel, giving you the 1X. And y'all, that's a negative something. So let me show you a trick. Reducing fractions. On this one, technically, I think I would have to take out a 4 from each of these numbers. But when you're weak at doing that, reducing, watch this. I'm going to go to my calculator. I'm going to punch in a -8 divided by 60. Now remember, that's going to give me a decimal. So to turn the decimal back into a fraction, I'm going to hit math, enter. And I get a -2/15. Now, if you do it like this and you do the alpha y method and you do the ND, if you put the -8 on top and arrow down and do the 60, if you start out with it looking like a fraction, guess what? When I hit enter, it'll give me a fraction. So either way, it'll get that -2/15, okay? But y'all, what they basically did, they divided both of them numbers by 4. So 8 divided by 4 gave me the 2. 60 divided by 4 gave us the 15. All right, y'all, v squared minus 6v minus 16 equals 0. So remember, we had somewhere we had to factor, so that's what they're doing here, is getting you practice at factoring. So I got a v squared, it'll be a v and a v. The last number is negative, so I got a positive and a negative. So I need factors of 16, that'll subtract and get me a 6. So let's see, what's factors of 16? 1 and 16, 4 and 4, but oh, what about 2 and 8? And then 4 and 4. The ones that'll give you a 6 are 8 and 2. The 8's larger, so it's negative like the middle number. So you got a -8, +2. And then remember, at that point, you set both them equal to 0. So remember, I get a -2 for the first one. And then add 8. And I get a +8. Now remember, in support, you got to put both these answers, okay? In college algebra 9.6 on the log equations, you can't keep the negatives. But y'all, we're not dealing with logs here. They're just teaching us how to factor. So write both answers when you do this, okay? Now remember, when you're finding these factors, do that trick Michelle told us, like her teacher did. Go to y equals and do 16 divided by x, and you'll find all these factors, okay? So the last one in support, solve by factoring again. 5x squared minus 7x minus 12 equals 0. Okay, so anytime you got a number in the front and you can't factor it out, your first step, multiply that 5 times that 12. 5 times 12 equals 60. So what you want to do, treat 60 like it's the last number now, and you want to find factors of 60 that'll subtract and get a 7. So remember, at this point, I'm going to come down with my parentheses. X squared is an x and an x. The last sign's negative, so one's positive, one's negative. Woo, factors of 60, that'll subtract and get me 7. So y'all, let's see. We got 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. And that's it. One pair of those will subtract and get me a 7. And that's at 12 and 5. Larger number 12 is going to be negative like the middle number. And the 5 will be positive. Now, here's the difference, remember. When you multiply that 5 to get your new product at the end, at this step, you got to divide the 5 back out. So it's like you're borrowing that 5, okay? But since you borrowed it, you then got to get it back out of here. Now, reduce this fraction. 5 divided by 5 is going to give me a 1. Can't do nothing to that, so I'm going to leave it at x minus 12 fifths, all equal to 0. So now you're going to what? Set both of these equal to 0. You know, over here, I'm going to subtract 1 from both sides. I get x is a negative 1. Here, I'm going to add the 12 fifths to both sides. So I'm just going to add that fraction to both sides. So I get my x equals a positive 12 fifths. So if you can get it to this point where you got it factored, change the signs to get the final answers. Okay. And then once again, this one was not a log equation, so we're going to keep both answers in to support. All righty, y'all. So guess what? I have no more material to teach you. That is it for college algebra. So we will come in Monday. We're going to review for test 4. Tuesday, I'm going to start reviewing you for the final exam. So next week, you don't have a heavy load, just a couple tests, okay?